everyone and welcome to Ved Foundation. I am Yogita Thande, competitive exam coach and founder of Ved Foundation. Today I am going to explain lesson heat for 6th and 7th standard students. This unit is useful for science competitive exam like Homi Bhabha Junior Scientist, Raman Young Scientist, Science Olympiad and other science competitive exam. So watch this video till the end and don't forget to like and share this video. And to get such useful videos, subscribe our channel Ved Foundation. Let us start. Heat. Heat is a form of energy. We can't consider heat as matter because properties of matter are matter has mass and matter occupies space. But heat does not have mass and it doesn't occupy space. But heat can do work, and that's why heat is a form of energy. Heat is defined as the energy that flows from one body to another because of difference in temperature. Heat is a form of energy which causes sensation of hotness or coldness. Temperature. The degree of hotness or coldness of a body is called temperature. Temperature determines the direction of flow of heat. Heat flows from body at higher temperature to a body at lower temperature. Student, amount of heat contained in a body is called heat capacity. Amount of heat contained in a body is not temperature. Temperature is degree of hotness or coldness is called temperature. Thermal equilibrium. When hot body is in contact with cold body, heat energy flows from hot body to the cold body till the temperature of both the bodies becomes equal. When both the bodies attain same temperature, they are said to be in thermal equilibrium. In this image, first body has a temperature 100 degree and the second body has temperature 0 degree. When two bodies are kept in contact, heat flows from body at higher temperature to the body at lower temperature till temperature of both the bodies become equal. Here, both bodies are in thermal equilibrium. Temperature. Temperature of a body depend on three factors. The amount of heat energy absorbed by the body. Second, the nature of the body. And third, mass of the body. Heat is a cause while temperature is an effect. As heat is expressed by magnitude only, heat is a scalar quantity. Units of heat. As heat is a form of energy, units of heat and units of energy are same. SI unit of heat is joule and CGS unit of heat is erg. And relation between joule and erg is 1 joule is equal to 10 raised to 7 erg. Other commonly used unit of heat is calorie. 1 calorie heat. 1 calorie is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. Or 1 calorie heat is the amount of heat lost when 1 gram of water is cooled by 1 degree Celsius. Relation between calorie and joule. 1 calorie is equal to 4.184 joule or 4.2 joules. For a large measurement of heat energy, the unit kilocalorie is used. 1 kilocalorie heat is the amount of heat needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. 1 kilocalorie means 1000 calorie and 1 kilocalorie is equal to 4200 joules. Heat capacity, it is also called thermal capacity. Heat capacity or thermal capacity is the amount of heat required to raise the temperature of substance by 1 degree Celsius. SI unit of heat capacity is joule per degree Celsius. Heat capacity is equal to specific heat capacity into mass of the substance. Specific heat capacity of a substance is defined as the amount of heat raised to raise the temperature of unit mass of substance by 1 degree Celsius. Specific heat capacity depends on following factors. First, nature of the material. Different substances need different quantities of heat for getting heated through the same range of temperature. Second, mass of the body. Quantity of heat required to heat the substance is proportional to the mass of the substance. More the mass, more is the quantity of heat required. Third, range of rise in temperature. Quantity of heat required to heat the substance is proportional to the rise in temperature. SI unit of heat capacity is joule per kg degree Celsius and CGS unit of specific heat capacity is calorie per gram degree Celsius. However, commonly used unit of specific heat capacity is joule per gram degree Celsius. Specific heat capacity of water is 4200 joule per kg degree Celsius or 4.2 joule per gram degree Celsius. Specific heat capacity of ice is 2100 joule per kg degree Celsius. Effects of heat. First, rise in temperature. When a body absorbs heat, the kinetic energy of its molecule increases. As a result, the temperature of the body rises. And due to the absorption of heat, the molecule constituting the body gains kinetic energy and move faster. And this makes the molecules farther apart, causing the body to expand. Means the effects of heat are first, rise in temperature. Second, expansion. Solid, liquid, gas. Matter in the form of three phases expand on heating. Next effect of heat is change in state. Change of state. Heat causes the change in state of a matter. On heating solids, solid convert into liquid state and liquid convert into gaseous state. And on cooling, gases convert into liquids and liquids convert into solids. On cooling, gases convert into liquids and liquids convert into solids. Chemical change. Heat can cause chemical change. Heat causes chemical changes in some substances. For example, combustion. Combustion is a chemical change. When heat absorbed by a body causes the temperature of the body to rise to its kindling temperature and then combustion takes place. Kindling temperature is the temperature at which substance starts burning. The kindling temperature. The temperature at which a substance starts burning is called kindling temperature. Kindling temperature of different substances is different. Combustion means burning. Combustion is the process by which a substance reacts chemically with oxygen in the air to produce heat and light. So these are the effects of heat. So effects of heat are rise in temperature, expansion, change in state, chemical change. Flammable and non-flammable substances. Combustible substances or flammable substances. Substances which burn easily are called combustible or flammable substances. For example, LPG gas, kerosene, petrol, diesel, spirit, nylon, paper, alcohol. These are combustible substances. They catch fire easily. Non-combustible or non-flammable substances. Substances that do not burn easily are called non-flammable or non-combustible substances. For example, metals are non-combustible, stone, rocks, soil, copper. These are non-combustible substances. Expansions in substances. First, we will learn expansion in solid. So, heat causes expansion in solid, liquids and gases. Expansion in solids because of heat. That is also called thermal expansion in solid. Different solids expand by different extent with the same rise in temperature. Thermal expansion in solid may be of three types: linear expansion, superficial expansion, and cubical expansion. First, linear expansion. The expansion in the length of solid is called linear expansion. Second, superficial expansion. Expansion in the area of a solid is called superficial expansion. Third, cubical expansion. The expansion in the volume of a body is called cubical expansion. Thermal expansion in liquids. On heating, liquids expand in volume. The more the rise in temperature, the greater is the expansion. Different liquids expand by different amounts for the same rise in temperature. Thermal expansion in gases. On heating, gases expand in volume to a large extent. All the gases expand by the same extent for equal rise in temperature. Liquids and gases show only cubical expansion but no linear and superficial expansion because they do not have definite shape. Heat transfer. The transfer of thermal energy between substances due to the difference in their temperature is called heat transfer. Heat transfer takes place in three ways: conduction, convection, radiation. They are also called modes of heat transfer. Mode of heat transfer: conduction. Conduction is the process of heat transfer from one particle to the next particle in solid without the particle actually moving from their position. Conduction takes place in solids. Conduction requires material medium. Conduction is not possible in vacuum. See here, the rod is heated at the one end. The particles that get heat transfer heat to the neighboring particle next to the neighboring particle. In this way, heat transfer takes place from one end to other end. So conduction takes place in solid only, and conduction is the slowest mode of heat transfer among the different modes of heat transfer. In conduction, let us learn properties of conduction, characteristic of conduction. In conduction, particles do not leave their mean position. Because in solid, the particles do not change their place, they only vibrate in their own place. They transfer heat as a result of vibration about their mean position. Conduction is slow as compared to convection and radiation, and conduction is the slowest mode of heat transfer. Second mode of heat transfer is convection. Convection is the process of heat transfer in which the particles change their position by constantly moving from hotter region to the colder region, and causing heat energy to flow. This movement of particle in the form of current is called convection current. The hot particle move upward and upper cooler particle move downward. And in this way currents are formed, and these currents are called convection current. Simultaneous upward and downward movement of molecules in a liquid or gas caused on heating is called convection currents. Convection takes place in fluids only, means convection takes place in liquids and gases. Liquids and gases are fluids. Fluids means those substances which can flow easily, and liquids and gases are fluids. Convection is faster than conduction but slower than radiation. Consequences of convection. Sea breeze and land breeze occur due to the convection current. Air conditioners are placed near ceiling. Third mode of heat transfer is radiation. Radiation is defined as the method of heat transfer in which no material medium is required. Means radiation can take place through vacuum also. Means heat transfer through radiation takes place through vacuum. Means no material medium is required. Radiation is the transfer of heat by electromagnetic waves. Electromagnetic radiation travels at the speed of light. Electromagnetic radiations can travel through vacuum. So radiation is the fastest mode of heat transfer, and conduction is the slowest mode of heat transfer. We get heat from the sun by radiation. Radiant heat. Heat transferred from one body to another by radiation is called radiant heat. All hot objects, solid, liquid, gases, transfer heat by radiation. Black and dull and rough surfaces are better absorber of heat. Hence, they are good radiators also. The substances which are good absorber, they are good radiators of heat also. Shining, polished, or white surfaces are bad absorber of heat, hence they are also bad radiators of heat. Black body absorbs up to 95% of incident radiant heat, and white and light colored surfaces are bad absorber and bad radiators of heat. Practical applications of black and white surfaces. Utensils used for cooking purposes are painted black at the bottom from outside because black surfaces absorb a maximum amount of heat. The brightly polished teapot keep the tea warm for longer time because polished surfaces reflect heat. We wear white or light colored cloths in summer and dark colored cloth in winter because white or light colored cloths reflect heat and dark or black colored cloth absorb heat. Heater is provided with highly polished reflector. Hot water pipes, radiators of cars and cooling fans at the back of refrigerators are painted black so that they may radiate heat from water quickly and keep the temperature within limit. Radiant heat. The amount of heat radiated by body depends on temperature, surface area and distance of the body from the source. First, temperature. Higher the temperature, more is the radiant heat. Surface area, larger the surface area, more is the radiant heat. And third, distance of the body from the source, farther the body from the source, lesser is the radiant heat received. Heat radiated by a body is greater when the temperature or surface area of the body is more. Applications of radiation. The bottom of cooking utensils are blackened so that they may absorb and radiate more energy. Firemen wear highly polished and shiny suits. People wear white and light color cloths in summer. Room heaters have shiny reflectors to reflect the heat into the room. Spacecraft have silver or white surfaces to reflect the heat produced due to friction between the surface and atmosphere. Space thermal conductivity. The ability of a substance to conduct heat is called thermal conductivity. Based on thermal conductivity, substances are classified into two groups: good conductors of heat and poor conductor or bad conductors of heat. Good conductors of heat are also called thermal conductor and bad conductor of heat are also called thermal insulators. First, thermal conductor. Substances that allow heat to flow through them are called good conductors of heat. All metals are good conductor of heat. Silver is the best conductor of heat. And the non-metal graphite is good conductor of heat. Thermal insulator. Substances that do not allow heat energy to flow through them are called bad conductors of heat or thermal insulator. Examples of thermal insulators are glass, plastic, wood, ebonite, cotton, wood, rubber, wool, etc. Heat. Heat cause of change in state. Heat causes change of state. Let us learn term related to change of state. First, melting. The process by which solid convert into liquid state at a fixed temperature is called melting. And the fixed temperature at which solid changes to liquid state is called melting point. Melting point of different solids is different. Solidification, freezing. The process by which liquid changes to solid on cooling at a fixed temperature is called freezing. The fixed temperature at which freezing takes place is called freezing point. It is also called solidification point. Melting and freezing are reverse processes. During melting, solid converts into liquid state and during freezing, liquid converts into solid state. But both processes takes place at same temperature, means melting point and freezing point are same temperatures and have same numerical value. Melting point and freezing point of water is 0 degree Celsius. Next, boiling. The process by which a liquid changes to gas at a fixed temperature is called boiling. And the fixed temperature at which a liquid boils is called boiling point. Condensation. The process by which gas or vapor changes to liquid on cooling is called condensation. For example, water vapors convert into water by the process of condensation. Condensation takes place at particular or at a fixed temperature, and the fixed temperature at which vapor changes to liquid is called condensation point. Students, boiling and condensation are reverse processes. During boiling, liquid convert into gaseous state, and during condensation, gas convert into liquid state. Both are reverse processes, but both processes takes place at same temperature. Means boiling point and condensation points are same temperature and have same numerical value. For example, boiling point and condensation point of water is 100 degrees Celsius. Next term related to change of state is evaporation. Evaporation is a form of vaporization, but evaporation takes place below boiling point. So evaporation and boiling are two different forms of vaporization. Boiling takes place only at boiling point and evaporation takes place below boiling point at any room temperature. Evaporation depends on the following factors: temperature, humidity, surface area, and speed of wind. Temperature. Evaporation is faster if the liquid is at higher temperature. Means higher the temperature, faster is the evaporation. Next, humidity. Rate of evaporation is slow if humidity is more. Means less the humidity in air, faster is the evaporation. There is very less humidity in air in summer season, so evaporation is fast. Rate of evaporation is fast in summer. And in rainy season, there is more humidity in air, so rate of evaporation is slow during rainy season. Rate of evaporation depends on surface area also. Larger the surface area, faster is the evaporation. And as rate of evaporation depend on speed of wind. Greater wind speed, faster is the evaporation. Sublimation. The process by which solid directly changes into gaseous state without undergoing liquid state is called sublimation. In sublimation, liquid state is skipped. Solid directly convert into gas or gas directly convert into solid. And the substances that or the solids that directly convert from solid to gas or gas to solid are called sublimable substances. Examples of sublimable substances are camphor, naphthalene balls, means iodine, sal ammonium, dry ice. Let us learn effect of pressure on freezing point, boiling point. Effect of pressure on freezing point. Increase in pressure result in decreasing freezing point of a substance. For example, if you press two ice cubes, the freezing point of substance decreases and ice melt into water, and when you release force, the water again convert into ice and two ice cubes get stick to each other. Effect of pressure on boiling point. Increase in pressure result in increase in boiling point of a substance. Same principle is used in pressure cooker. In pressure cooker, increase in pressure increases boiling point of a substance, and that's why food is cooked in less time. Melting point and freezing point are the same temperature and have the same numerical value. Next, effect of addition of solute. Addition of solute decreases the freezing point of substance and increases the boiling point of substance. For example, if salt is added in ice, then freezing point decreases up to -23 degrees Celsius. And boiling point of this mixture also more than 100 degree. Means addition of solute increases boiling point and decreases freezing point. Anomalous behavior of water. Generally, substances expand on heating and contract on cooling. But water show abnormal or exceptional or strange behavior below 4 degrees Celsius. On cooling below 4 degrees Celsius, water expands instead of contracting. Conversely, if water is heated from 0 degrees Celsius to 4 degrees Celsius, instead of expanding, it contracts. And this behavior of water is known as the anomalous behavior of water. Examples of anomalous behavior of water. Survival of the aquatic plants and animals in frozen lakes is because of anomalous behavior of water. Because during winter in cold regions, temperature fall down below 0 degrees Celsius and water convert into ice. So when water convert into ice, its volume increases, density decreases and ice float on water, and a layer of ice is formed on water. But below this ice layer, there is a water at 4 degrees Celsius. Density of water is maximum at 4 degrees Celsius. And because of this, aquatic life can survive. Next, bursting of water pipes during winter. During winter, sometime temperature fall down below 0 degrees Celsius and water in pipe freeze and convert into ice. And when water convert into ice, its volume increases, and this increased volume exert pressure on the walls of pipe, and that's why pipes burst during winter. Crumbling of rocks into pieces. During rainy season, water collects in the cracks of rocks. During winter seasons, this collected water freeze and convert into ice. And ice means increase in volume, and this increased volume exert pressure on the walls of the rock, and rocks crumble into pieces. Bottle filled with water cracks in freezer. Bottle completely filled with water. If you put this water in freezer, the water convert into ice and expand. And as there is no space for the expansion, bottle cracks. In Hof's separator, bottom thermometer reading is constant 4 degrees Celsius because density of water is maximum at 4 degrees Celsius. Next, latent heat. Latent means hidden. Latent heat means hidden heat. Heat absorbed or released by a unit mass of substance to change its state completely is known as latent heat. Solid absorb heat to convert into liquid state. So the heat absorbed by solid to convert into liquid state is called latent heat. In the same way, liquid absorb heat to convert into gaseous state, that is also called latent heat. So latent heat is of two types: latent heat of fusion and latent heat of vaporization. Let us learn first latent heat of fusion. Fusion means melting. Fusion is synonym of melting. The quantity of heat absorbed by unit mass of substance to change its state from solid to liquid at the melting point is known as latent heat of vaporization. So solid absorb heat and then convert into liquid state. So the heat absorbed by solid to convert into liquid state is latent heat of fusion. And latent heat of fusion of ice is 80 calorie per gram. Next, latent heat of vaporization. Quantity of heat absorbed by a unit mass of substance to change completely from liquid to gas at the boiling point is called latent heat of vaporization. Liquid absorbs heat to convert into gaseous state, and this heat absorbed by liquid is called latent heat of vaporization. Latent heat of vaporization of water is 540 calorie per gram. SI unit of latent heat is joule per kilogram and CGS unit is calorie per gram. Thermal equilibrium. If two substances are in contact, thermal energy transfers from substance at higher temperature to the substance at lower temperature until temperature of both the substances become equal. And this state of substances in which the heat transfer takes place from one substance to another substance and both substances attain equal temperature is known as thermal equilibrium. Principle of heat exchange. Where heat is lost by hot body is equal to heat gained by cold body, and this is the principle of heat exchange. Heat lost by hot body equal to heat gained by cold body. And heat absorbed or heat lost is calculated by the formula MST. M stands for mass, S for specific heat, and T for rise in temperature. And heat loss is equal to mass into specific heat capacity into fall in temperature. So principle of heat exchange is heat lost by hot body is equal to heat gained by cold body. Sensible heat. The heat lost or gained by a body resulting in change in temperature is called sensible heat. So sensible heat means the heat absorbed by an object to change its state. Heat capacity is equal to mass into specific heat capacity into change in temperature. Q is equal to M into C into difference of temperature T1 minus T2. The amount of sensible heat gained or lost by body is denoted by Q. M is the mass of the body and C is specific heat capacity. T1 and T2 are two temperatures denoting temperature range. Conductors and insulators. Materials that allow heat to pass through them are called good conductors of heat. Metals are good conductors of heat. Practical applications of conductors. The cooking utensils are made up of metals because they are good conductors of heat. So they will allow the heat of the flame to pass through them, which is required to cook the food. Mercury is used as thermometric liquid because mercury is a good conductor of heat. Automobile radiators use tubes made of copper as copper is the good conductor of heat. Air conditioners and refrigerators use copper tubes because copper is good conductor of heat. The heat is passed onto the solder through the tip of soldering iron, which is made up of copper, as copper is a good conductor of heat. Insulators. Materials that do not allow heat to pass through them are called insulators or thermal insulators. Substances like glass, wood, plastic, rubber, non-metals, air, pure water, these are insulators. They do not allow heat to pass through them. Applications of insulators in our day-to-day life. Handles of cooking utensils are made up of insulators so that we can hold them through the insulated handle which do not become hot even when the utensil is very hot and our hand does not burn. We wear woolen cloths and use blankets in winter as they contain large amount of trapped air, which is a bad conductor of heat. Air is a bad conductor of heat and air get trapped in the holes of woolen cloths or blanket, and this layer of air act like insulator. Thus our body stops losing heat and we feel warm. The gap between double walls of an ice cream box is filled with glass, wool, which is bad conductor of heat. It prevents the heat from the heat flowing in so that ice does not melt. Measurement of temperature. Temperature is hotness or coldness of a body, and temperature is measured using thermometer. SI unit of temperature is Kelvin, and other units used to measure temperature are Celsius and Fahrenheit. Celsius scale. So there are three temperature scales: Celsius scale, Fahrenheit scale, Kelvin scale. In Celsius scale there are 100 divisions. from 0 degree Celsius to 100 degree Celsius, and this scale is was invented by Swedish astronomer Anders Celsius in 1701 to 1744. Fahrenheit scale. In Fahrenheit scale, there are 180 divisions from 32 degree Fahrenheit to 212 degree Fahrenheit. 32 degree Fahrenheit means 0 degree Celsius and 212 degree Fahrenheit means 100 degree Celsius. So there are 180 divisions. If you subtract 32 from 212, you will get 180. Means in Fahrenheit scale, there are 180 divisions. And they are from 32 degree Fahrenheit to 212 degree Fahrenheit. And third temperature scale is Kelvin scale. And Kelvin is the SI unit of temperature. So Kelvin scale is a theoretical scale. It is not measured with the help of thermometer. Kelvin scale is obtained using formula. And using the formula, we can convert Celsius scale into Fahrenheit, Celsius scale into Kelvin scale, and Fahrenheit scale into Kelvin scale. Celsius temperature can be converted into Kelvin temperature by simply adding 273. If you add 273 in Celsius scale, then you will get Kelvin scale. For example, 0 degree Celsius is equal to 0 plus 273 means 273 Kelvin. 1 degree Celsius means 1 plus 273 means 274 Kelvin. In this way, we can change Kelvin scale into Celsius scale or Celsius scale into Fahrenheit scale. So these are the formulas to convert Kelvin into Celsius or Celsius into Fahrenheit and vice versa. 0 degree Celsius means 273 Kelvin. To get Kelvin scale, we have to add 273 in the reading given in Celsius scale. So 0 degree Celsius means add 273 in Celsius reading. 0 plus 273 means 273 Kelvin. Absolute zero temperature. Absolute zero temperature means 0 Kelvin. 0 Kelvin temperature is called absolute zero temperature because this is super low temperature, and at this temperature the particles in matter freeze. They lose their all energy, kinetic energy. They do not move, and all the molecules unite together to form super molecule. So this temperature is called absolute zero temperature, or 0 Kelvin, or minus 273 degrees Celsius. These are the formulas to convert Fahrenheit reading into Celsius reading, Celsius into Fahrenheit, etc. This is the formula. So Fahrenheit, 0 degree Fahrenheit is equal to 0 degree Celsius into 9 upon 5. First solve this bracket and then add 32 in the answer. Celsius reading into 9 upon 5. Fahrenheit is equal to Celsius reading into 9 upon 5 plus 32. So if you put value of Celsius reading 100 degree, and if you find, you will get the temperature 21 degree Fahrenheit. This means that 100 degree Celsius is equal to 212 degree Fahrenheit. 0 degree Celsius is equal to 32 degree Fahrenheit. Students, Celsius reading and Fahrenheit reading show different numerical values at the same temperature. 100 degree Celsius is equal to 212 degree Fahrenheit. It doesn't mean that the temperatures are different. Temperature is same, but the numerical values are different because of different temperature scale. But at minus 40, both scales show equal values. Celsius scale and Fahrenheit scale show equal reading, equal numerical value at minus 40. Means minus 40 degree Celsius is equal to minus 40 degree Fahrenheit. Different liquids are used in thermometer. Thermometer is the instrument that is used to measure temperature, and different liquids like alcohol and mercury are used in thermometer. Liquid used in thermometer, alcohol. Alcohol is used in thermometer because of its unique properties. Freezing point of alcohol is very low, minus 117 degrees Celsius. So if alcohol is used in thermometer, very low range of temperature can be measured. Means below 0 degrees Celsius up to minus 117 degrees Celsius. Very low temperatures can be measured. It is used to measure very low temperature and to study weather conditions and atmosphere. At polar region, the scientists use alcohol thermometer to measure very low temperature. Reasons for choosing alcohol as the thermometric liquid. These are the reasons for choosing alcohol as in thermometer. First, alcohol has very low freezing point. Alcohol does not freeze easily and its freezing point is minus 117 degrees Celsius. And that's why we can measure very low temperature using thermometer, alcohol thermometer. Alcohol expand more than mercury for each degree rise in temperature, and that's why this makes the thermometer more sensitive and we get accurate reading. It expands uniformly over a fairly large range of temperature. Because of these reasons, alcohol used in thermometer. Next liquid used in thermometer is mercury. Mercury is used in thermometer because there is a large difference between melting point and boiling point of mercury. Melting point of mercury is minus 39 degrees Celsius and boiling point is 357 degrees Celsius. Means mercury does not freeze easily or does not boil easily. There is a large difference. So using mercury in thermometer, we can measure large range of temperature from 39 to 357 degrees Celsius. There are other reasons also to choose mercury as a thermometric liquid, and they are: mercury is a shiny metal. It has silvery look and that's why it can be easily seen through glass. It expands and contracts uniformly because it is good conductor of heat. Mercury is the only liquid metal and so it can flow. We can't use solid metals in thermometer because they are in solid state, but metal strips are also used to measure temperature. That is called pyrometer. It does not stick to the glass and that's why we get accurate reading. It does not freeze or vaporize easily. There is large difference between melting and boiling point of mercury. So we can measure large range of temperature using mercury in thermometer. So because of this reason, alcohol and mercury is used in thermometer. A thermometer is calibrated. To calibrate means to make the markings on the basis of lower and upper fixed point. So the lower fixed point is the temperature at which pure ice melt. Pure ice melt at 0 degrees Celsius means the lower fixed point of thermometer is 0 degrees Celsius. Upper fixed point, the thermometer is kept in boiling water and level of mercury is marked, and this is upper fixed point of the thermometer. So upper fixed point means the temperature at which pure water boils and boiling point of water is 100 degrees Celsius. So upper fixed point of the thermometer is 100 degrees Celsius. Then the gap between 0 degrees Celsius to 100 degrees Celsius is divided into equal 100 parts. In this way, thermometer is calibrated. Different types of thermometer. There are different types of thermometer like clinical thermometer, laboratory thermometer, maximum and minimum thermometer. Clinical thermometer. Clinical thermometer is used to measure body temperature. In hospitals and in dispensaries, clinical thermometer is used to measure human body temperature. You know that normal human body temperature is 37 degrees Celsius. So the markings on clinical thermometer are from 35 degrees Celsius to 42 degrees Celsius. And here normal human body temperature. A clinical thermometer consists of long, narrow, uniform glass tube with a small shining thread of mercury. This is the very narrow capillary tube, and this is the outer glass tube, and this is bulb, and in this bulb there is mercury. There is a bulb at one end which contain mercury and cling inside, which does not allow mercury to fall when thermometer is taken out of the mouth. Cling, here is the small cling that is not shown here. Cling means bent part. Normal human body temperature in the Celsius scale is 37 degrees Celsius, and on the Fahrenheit scale is 98.4 degrees Celsius. Sometimes both scales are given on clinical thermometer, upper side Celsius, lower side Fahrenheit. Laboratory thermometer. Laboratory thermometer is used in laboratory for measurement of temperature of chemicals and for other purposes. Marking on laboratory thermometer are from -10 degrees Celsius to 110 degrees Celsius. Laboratory thermometer consists of long, narrow, uniform glass tube having bulb at one end filled with mercury. This is the outer glass tube, and this is inner glass capillary tube. This is very thin, and at the end of inner glass capillary tube there is a bulb containing mercury. Maximum and minimum thermometer. Maximum and minimum thermometer is also known as sixth thermometer and is used to measure maximum and minimum temperature of the day at particular space. Maximum and minimum thermometer is used in meteorology for forecasting weather conditions. Thermos flask. It is also called Devor's whistle, as it was invented by Sir James Devor, a British scientist, in 1890. Thermos flask is the whistle in which things are maintained at their temperature for a longer time. Hot things remain hot and cold things remain cold for a long time in thermos flask. This is the construction of thermos flask. It is made up of two wall thin glass vessels. These are the two glass vessels having two walls. This is outer wall and this is inner wall. And in the two glass walls there is vacuum. There is vacuum between the two glass walls. The inner surface of the outer wall and the outer surface of the inner wall are silvered. Inner surface of the outer wall and outer surface of the inner wall means the inside area, the inside sides of the walls, glass walls are silvered. The mouth of the flask is stoppered with plastic cap. This is stopper, plastic stopper. Heat transfer is minimized in the vacuum flask in the following ways. The vacuum between two walls of the glass vessels prevent heat transfer by conduction or convection. Because conduction and convection does not take place through vacuum. So because of vacuum, heat transfer is minimized. Heat transfer by conduction and convection is minimized. The polished surfaces of the glass wall reflect heat and thus prevent heat transfer by radiation. Okay, so through this vacuum, heat transfer can take place only through radiation, but heat transfer through radiation is also minimized by painting the inner walls of the glass vessel silver with silver color. The plastic body and this glass double wall glass vessel is kept in plastic container because plastic is bad conductor of heat. So the plastic body and cap are bad conductors of heat and they minimize heat transfer. In this way, heat transfer is minimized in vacuum flask, and that's why hot substances remain hot and cold substances remain cold for long time. Thank you for watching.